Okay, so the collision system. So I'm gonna start out within the one of the scenes. So prior to game object being able to register itself to detect collisions within the scene, the collision pairs have to be set. So that's what's happening right here. Set collision pair. This creates a collision pair command. Collision manager. Actually, let me just go through the channels. So base class of the scene base class has a method set collision pair templated, which creates a collision test pair command when called. So yeah. So the collision test pair is created. These are what these are used for testing collisions between each of the actual individual collidable objects. Um, so within collision manager, yes, yes. So the list of um, collision commands are stored within a collision manager, and when process collisions is called, it iterates through all of the collision pairs and tests all of the performs all of the tests associated with them. Um, so yeah, so collision manager, it's just like all the other multi-tins. It's stored within scene, and it's called within the update. So yeah. Um, so now going over to the actual collidable object. So ship, for instance, uh, I wanted to be able to detect collisions, so um, I register itself to be collidable. Um, so this goes up to collidable. Creates a new registration commands. Goes through all the normal channels, passes it to the scene, executes it, registers the actual object. Um, Here I'm actually gonna. Actually, I can just jump over here. Scene attorney submit scene command. So actually, looking in collision registration command. Where is that? Here it is. Okay, yeah. So it gets registered to a collision group um, when it's actually registered. Collision groups are, well, it's a class that essentially stores all of the objects that have registered for collision of type C. So let me just pull that up. Collision group attorney. It's this one, right? No, it's this one. Yes. Okay. So an object is registered to a given collidable group. It's inserted inside of the collection, and then yeah, so it's registered inside of the collection, and then this collection is, well, it stores all of the collidables of the given type C. Um, and then when the collision pair tests are actually performed within Collision Manager, that's when this collection is accessed and iterated through to test all of the collisions between all of the registered pairs. So I can now jump into, process collision tests. So now jumping into the actual collision tests. So I'll pull up test pair. So when execute gets called from the collision manager, what this essentially does is, as I just said, it grabs the, actually, yeah, it has a reference to the, it's storing the list for the collidable groups, and then when this is executed, it actually tests, it runs intersection tests between the objects in this collection with the object in the other collection, and yeah, that's what's happening in here. So yeah. So actually, so this is where it's testing to see if the objects are colliding. So it's grabbing the B spheres for the assigned, that are assigned to the collidable objects, and then it's running an intersection test between the two. And then if it is colliding, then it'll run the collision scripts for the objects. So where's ship? Pull up ship. So it actually, so down here, so if say for example ship detects a collision with an enemy, then this will get called on the ship, and then on the enemy do I have it here? I might have. Yeah. And then this will get called on the enemy. Test pair. And then most of this stuff is just for the visualizer. This draws the visual representation of the B-sphere around each of the collidable objects. This is just a additional test I was doing just to get the visualizer to work. So anyways, so jumping into actually the actual collisions, so as I mentioned, the collidable objects have B-spheres on them, which are stored inside of their collidable class. Let me pull that up. So yeah, here. So it's storing a B-sphere which represents its collision volume. The B-spheres are just, if I remember correctly, they're just a vector and a referring to the point, and a float referring to their radius. Yes. And this is just for additional visualizer testing. I'll talk more about the visualizer later. So yeah, B-spheres, all they are a vector representing their center within the world, and a float representing their radius. So yeah. So look, going back into collidable. So in order to get the B-sphere measurements, the information for the B-sphere, I have to call, is it set collider model? Update collision. It's one of these two. Set collider model. No, this sets the model. Okay. Yeah. So I have to grab the model of the object that I want to detect collisions on. So I believe I do it in here. Set world. Set collider model. Okay. So set collider model, I'm passing my model to be yeah, I pass it there. What do you call it? Where I actually compute the of course. It's been a while since I looked at everything. Anyway, so I set the collider model, pass that back to the collidable class attached to the ship object. Then within the update, that's where I'm getting my where I'm computing my new center and the radius that corresponds to the model that I pass back within compute data here, which compute data, which just gets me my radius and new center. So yeah. So all that gives me my B-sphere that I'm using to test collisions, and then back in collision test pair. So now that these essentially have a radius and a center, I can then, both of these, I can then test to see if the two are intersecting. So within math tools, it's just a small calculation to see if the distance between, let me actually pull it up. Math tools is just a static class, by the way. So I'm just testing to see if the distance between the two centers of the B-spheres is closer than the sum of the radiuses. So if it's larger, if the distance is larger than the sum of the radiuses, then they can't be touching. But if it's shorter than the sum of the radiuses, then obviously they're colliding. They're overlapping to some extent. So yeah, So this will return either true or false, whether or not they're colliding. Call their collision scripts, and then okay. So I guess I can go into the visualizer now. The visualizer, as I mentioned before, all it does is it takes the measurements of the B-spheres and generates a visual representation of what it looks like. So actually going into this. Show B-spheres. Good definition. Oh, duh. Okay. So add command. Do I? Okay. Okay. Okay, yeah, I remember now. All right. So within, where was it? Nope, not there. Where's the visualizer? Let me see. Inputable. There we go. Okay. All right. So I get my radius and center from the B-sphere, as well as the color that I passed in. And then I pass that to the draw broker. The draw broker then creates a command which essentially holds all that data. Oh, not a radius, my world for the B sphere. My world matrix for the B sphere. I create a visualizer draw command. This stores a matrix, the actual sphere, and the color, and then yeah, those commands are stored within the draw broker. And then so then in visualizer, did I process? Yeah, okay. So visualizer, it's holding the draw broker. So what happens is when the visualizer calls process elements on the draw broker, that's when it renders all of the B spheres from the visualizer draw commands using their passed in matrix and vector color. So this happens within the visual processing happens within the base scene. So yeah, right here. After all of the normal models are drawn, then the wireframe representation of the collision objects are drawn. So yes, I believe that's essentially it for the collisions and everything. Collision test pairs. Yes. And then all the registration stuff, it's pretty standard compared to the other levels. But yeah, that's it for collisions.